Alright, today we are going to look at different work. We're going to look at chains first. We're actually going to look at chains and Boyle's Law, but we're going to do chains first. So a 40-foot chain weighing 3 pounds per foot is coiled on the ground. How much work to raise one end of the chain to 20 feet? Okay, so you have this chain on the ground, and you're going to raise one end 20 feet. Now, I would draw my coordinate plane in here. I'd put this bad boy right on the x and y axis so that you have a height of y no matter where you are. So once again, work is force times distance, and your distance has an equation this time, and your force kind of has one too, because the change in force is a weight. Okay, your weight of your chain was 3 pounds per foot. Okay, to get rid of the feet there, come on, we would have to multiply by some sort of feet, the length of the chain. Well, the length of the chain is changing, right? It's changing in small little increments. So if it's changing in small little increments, that's delta y. But the nice thing is that does get rid of these feet. So my weight, or my force, my change in force, is 3 delta y. Alright, now the distance. These little increments, if I start pulling the chain up a little bit, or if I pull it up a little bit more, a little bit more, a little bit more, we don't know the number, but it's going up the y-axis, so the distance on this one is just y. So my work is going to equal force times distance, so 3 delta y, y, or 3y dy. And how far do I want to lift the chain? I want to lift it all the way to 20, and I start at 0. And I know you guys can integrate that one. Alright, so the next problem that we want to look at is Boyle's Law.